In 10.2, we are graphing linear equations. So there, we're going to first work on when we are given the equation, making the graph. And then on the other side, we're going to work on when we are given the graph, making the equation. Here are your steps when you are graphing linear equations. If the equation's slope-intercept form, y equals mx plus b form, you'll plot you put the equation y equals mx plus b, then you find your y-intercept, where across the y-axis. That is b, okay? So that you just put a dot there, and then we'll use a slope to create more points. After you create 2-3 points, then you connect into a line. So let's look at our first one, for example. Y equals negative x plus 3, right? I'm going to highlight your y-intercept. That is where across the y-axis, all right? So across the y-axis at positive 3, so let's look for positive 3 on the coordinate plane on the y-axis. So 1, 2, 3. So we're 0, x value is 0, y value is 3. That's where the y-intercept is. My slope is this guy right there. It's a negative 1. So my slope is m equals negative 1 over 1. The top means we rise, and the bottom means we run. So what that means is I'm going to make my next point by starting at the y-intercept. I'm going to go down 1, since it's a negative, and then go to the right 1. Okay? I'm going to erase those spots so that way we can see the next dot. But I go down 1 to the right 1. Again, down 1 to the right 1. I made 2-3 dots. You can put more if you want to, but you get the point that that is what the ugly looking line. It's still an ugly looking line. That's better. That's what I was trying to go for. Obviously not drawing the scale. I can't draw a perfect line with this pen, but there's that linear equation dotting all those points together. The next question, I got y equals 3x minus 4. It's already set in slope-intercept form, so let's go ahead and find what the y-intercept is. Here's the y-intercept. I'm going to look for negative 4 on the y-axis, so 1, 2, 3, 4. I'll put a dot there. My slope is m equals 3 over 1. Where did I get the 1 from, by the way? Under every whole number, there's invincible oneness, and we're going to utilize that invincible one when we're doing rise over run. So I'm going to rise 1, 2, 3 places, and run 1 place. Value, positive value. Okay, I'm going to erase those kind of lines I drew. So again, 1, 2, 3, right 1. And again, I'm going to erase those so that way that's not in the way. Then try to do your best to draw this. Oops, I did not mean to put eraser. I meant to put a pen. There we go. Not the best line, but connect the dots on your graph, and there is your linear graph. Let's look at one more, then let's see what happens if it's not set up in slope-intercept form. All right, obviously in your paper too, probably, you have, missing a fraction bar, but that's 2 over 5. My y-intercept is positive 2, so look for positive 2 on the y-intercept, and then we'll make our graph based on that point. So I'm going to go rise, positive 2 place, since it's a fraction already for me. Don't have to make it a fraction or fraction. It's already a fraction for me. So I rise 2 places, go to the right. 1, 2, 3, 4, 5. I go to the right 5 places. Feel free to go the other direction if you want to. So I can go down 2 and negative 5. And how I could do that if it was a positive numerator, positive denominator. Well, if you remember, a negative divided by negative is a positive. Positive. This is basically a fraction, or a division problem. A fraction. That is connected to the three dots together, and there's that line. Better line than I had the others. And I have a standard form. Here's a standard form. Yesterday we worked on from standard form to slope-intercept form. So I'm doing the same thing. I'm subtract x from both sides of the equal sign. Cancel out on the left side, leaving 2y equals negative x plus 4. The goal is get the y by itself, so I'm divided by 2 from both sides of the equal sign, leaving y equals negative 1/2 x plus 2. Okay, we're going to use that as our information to make our graph. So when I make that graph, I'm going to look for positive 2 as my y-intercept. I went down 1, left, right 2. Down 1, right 2. Or, going back to the y-intercept, I can go up 1, left 2. You can make it as many points as you like to, but notice that it's going pretty consistently. So once you make as the numbers you want, connect your dots to make your straight line. The last couple sections, or last section of your 10.2. If you're given a graph, how to change it to an equation. First, identify the slope. And it would be helpful I got my pencil out. And your y-intercept. And then we'll change it to slope-intercept form. What slope-intercept form? Y equals mx plus b. Again, feel free to pause the video if you need to pause that to get that information. So for number 1, here's my graph. Let's first find where the y-intercept is. That's where it crossed the y-axis. Here it is right here. So here's B. Okay, let's figure out how far up or down from the origin I went to get to B. Negative 1, 2, 3. B equals negative 3. I'm going to go ahead and erase that now. And I'm going to find out my slope. Here's how I'm going to find my slope. I'm going to start at one order pair. I'll start here, and I'll count up. 1, 2, 3. That's my rise. And then I'm going to go right or left to meet the next point. If I go left, I'm not going towards the graph. Like I'm not going towards the graph, I go that way. I am going towards the graph, I go this way. And I went one place to the right to meet the next point. So my rise over run is 3 over 1 or 3. So my equation, we'll keep y equals, take out the m, put 3 in its place, and then the x minus 3. The second example, all right, first, again, find your y-intercept. Here it is right there. That's my b. So let's look for how far up or down. I went up 1, 2 places, so my b is going to be 2. And my slope is going to be going down 1, 2, 3. So I went down negative 3 places. Then went right, 1, 2, went right positive 2 places, so negative 3 over 2. Always simplify your fractions, which we can't simplify that, so we'll leave it as negative 3 over 2, and y equal negative 3 over 2, x plus 2. I'll show you one more. This time, it doesn't give me what my slope is, so that's okay. We can still do that. Here's my b. That's my y-intercept. So I know my b equals positive 3. Let's start from the bottom point. That's just my preference. I like to start from left to right like I'm reading a book. So I'm starting at this point here. 1, 2, 3. and went right, 1, 2. So 3 over 2. So my equation is y equals 3 over 2x plus 3. All right, I'm going to cut this part off, and then I'm going to show you on your Peer Deck assignment how to submit or how to write when you're graphing it, and how you're going to write your equations when you are looking at a graph. All right, so I'll give you all a free answer for your assignment for today, but we are going to look at number 1, and this is graphing the equation. We have talked about graphing equations on the Peer Deck before, but just kind of review how to graph it so that way you get the answer correct. So here we got negative 2 over 5x minus 3. You could either do two options. You can plug it on Desmos, or you can know that the b is the y-intercept, which is negative 3, and your rate of change or slope is negative 2 over 5. So I can plug it on Desmos if I want to. And I can pick 2 points on the graph. Don't matter what the points are. I won't use that one, but I'll use this. So 0, negative 3. And then I can go up 2 and to the right 5, or down 2 to the right 5. Either option, it doesn't matter which order pairs. All that matters is how the graph is graphed on the, or how the line is angled on the coordinate plane. So the order pairs don't matter. If you want to use the ones I use, feel free to do that. If you want to use two different ones, as long as that angle is the same, or if those order pairs are part of the graph. How to find different order pairs on Desmos, you can always click that settings button or that wheel button. Then click on the table, and then you can change the x values on the left side to whatever, and it will go to the y values that you need. So say maybe if I want to put 4, okay, 4 won't work, so I'll try a different. I'll try a different number. Let me try 6. 6 doesn't work. Maybe 5. Okay, 5 and negative 5. If you want to use those as your order pairs, 0, negative 3, and 5 and negative 5, that can work too. Again, it doesn't matter your order pairs as long as it's part of that graph.